Okay, so I feel like the first thing we should do is actually label the direction of the gravitational fields, right? Remember that gravity is always toward a mass, so the gravity due to mass B is that way. So here is GB, Great Britain is to the left. Okay, and then this gravitational field will be that way. G sub A is up and to the right. Okay, and let's figure out what that direction is. So this guy is just in the negative x direction. So GB is going to be in the negative direction and then not at all in the y direction. GA is going to be positive x and positive y. Let's figure out what this angle is. And I always find the angle with x because I'm lazy. I always want cos to give me an x component and sine to give me a y. So let's figure this out. That angle is going to be, theta is a tan of, what is it, 1, 2, 3 divided by 1. 3 over 1, opposite over adjacent side. So second tan of 3. And that's 71.565 degrees. Okay. All right. And now we got to figure out what these different gravity fields are. So let's figure out the G of A. And that's going to be, we're using the formula GM over R squared, right? So it'll be 6.67 E minus 11. So when I put E means times 10 to the 6.67 times 10 to the minus 11th, just like your calculator displays it. And then let's see, A is 2.5. Is 12 tera? I feel like it is. 2.5 tera kilograms, which is a weird thing to say, right? All right, let's see, 2.5 times 10 to the 12th. And then our distance to A is the square root of 1 squared plus 3 squared, but then we're going to square that. So we end up with 1 squared plus 3 squared. Right, again, remember it's the square root of that, but then that's squared, so we end up with that. All right, let's do this. I'm going to go alpha F1, got a fraction, 6.67 minus 11 times 2.5 E12, and then 1 squared and 3 squared in the denominator. 16.675. And that is newtons per kilogram. And that is up and to the right at an angle of 71.565 degrees with the x-axis. Okay, so GB is just going to be to the left. Okay, so it's going to be 6.67 E minus 11. B is 5.1 tera kilograms. I think that's funny because kilo is already a metric prefix. So a tera kilo is a, God, what's the next one? I don't know. Let's see, 12. What's above tera? There is one. What is it? Mega, giga, tera, peta? Is it peta? I think it's peta. Petagrams. 5.1 petagrams. Sorry. Okay, let's see. 1, 2, 3. 3 squared. Okay, so let's do that. I'm not so lazy that I'm just reusing my old thing. Okay, maybe I am that lazy. Okay, so hold on. 5.1, is that right? 5.1 petagrams, tera kilograms, pterodactyl. Here we go. Ooh, 37.7966666. All right. Okay, and this is just to the left. Okay, so let's make our little table here. So we're going to write the name of the charge, the name, the magnitude of the G field due to that, oh, not charge, name of the mass, the magnitude of the G field due to that mass, the direction, the x component and the y component. Wow, look at that. And then they're going to go g of a, g of b, okay, magnitude, that's enough space, direction, okay. I feel like I want to make it cozy. I'm going to put a little thing there. Oh, look at that, huh? If I don't do it for you, you do it for yourself, right? Okay, so A has a magnitude of 16.675. And the direction of A is, it's going to be a positive x, positive y. Okay? And it's 71.565 degrees above the x-axis, and that's why this is positive and that's positive. And then B is 37.796 bar, and it is just to the left, okay? Because if you're here, it's going to be straight that way, right? So this is going to be negative x and 0. No y. There will be no y component. There will be no y component for that. Okay, I can do this. Okay, so let's figure out these components. Since I've found all these angles are just with the x-axis, or well, this angle is, right? I'm going to use cos for this guy and sine for this guy. And I don't even need, whatever comes out of my calculator will be correct. So 16, unless you're in radians. That's sad. Okay, so 16.675 cos. I got to find that angle. Where is it? There it is. Right parenthesis, enter. I'm getting 5.273. And then I'm expecting my y component to be much larger. So then I just do the same expression, only I make it to sine. And I'm getting 15.819. Let's just double check our components. So our x component should be positive and our y should be positive. Our y should be bigger than our x, and indeed it is. Okay, and then this guy is just 37.796 bar. And then none of it is in the y direction because it's just straight to the left. It's straight toward that. Okay, and you'll see a lot of that. So in like IB things, they'll give you one angle that's super easy. Okay, so are we ready for this? I'm going to go this plus this. So do minus that guy. Negative 32.524. I'm rounding, it's 52356, etc. Okay, and then this guy is just going to be positive 15.819. Okay, and now we're set. Let's draw a picture of this guy. And then up about half of that, right? And then this is our vector. Okay. So let's find that angle. That angle is going to be a tan of opposite, so 15.819. Right, this is our opposite side. This is our adjacent side, 32.524 divided by 32.524. We can do this. I'm going to go second tan. That guy divided by the opposite of this guy. I don't like negative numbers, so I'm just going to make it. There it is. So that's 25.9 degrees. To the left and up, 25.9 degrees above the x-axis. And then let's find the magnitude. Where can we find the magnitude? Let's do it right here. Right. the magnitude is the square root of 32.2524. Don't put your minus sign in there. Squared plus 15.819 squared. Okay, now on my TI calculator, this gets a bit tricky. I have to go left parenthesis, square root left parenthesis. I'm going to pop the 32 number in there, put a right parenthesis on it, and square it. That's the only way to make that a positive number. Plus 15, which is already positive, squared, and now I'm set. And that's 36.2 is what our magnitude is. Newtons per kilogram. When you get this much writing on the slide, this version of PowerPoint gets kind of boozy. 36.2. Yeah, there we go. We're good. We got it. You guys are so smart.